Better now?
Good morning, everyone. Today we are here at the CA Datacom Cadre Virtual Customer Technical Conference. Our next speaker is Clyde McPherson, who is a software engineer for U.S. Customs and Border Protection. I would like to ask everybody to please mute your lines by doing *6, and that at the end, whenever Clyde asks for questions, then you can unmute by doing #6. Okay? Take it away, Clyde.
Good morning, afternoon, evening, whoever. Can you all hear me, I hope? I'll respond. Okay, so we're talking about 15.1 and some good reasons to be on 15. So, by way of introduction here, a lot of these things have been added to release 15.1 post-GA. For those who are not familiar, CA is using an Agile development strategy on Datacom nowadays, so they're adding new features all the time. And a lot of these new features are actually ideas suggested by customers. And in addition, customers are involved in the verification of the new features as well as suggesting them. So what we're looking at here is a couple of major enhancements, or what I regard as major enhancements: the block alter 24/7, cable move 24/7. Another potentially very useful feature is what they're calling add native. We'll talk more about that. And some other minor changes, or perhaps less significant changes that have been shipped out as well. And finally, I'll talk about some enhancements that have been added in a couple of previous releases, because I find sometimes these things slip by. They slip by me, so I'm sure they slip by others as well, so we'll talk about those to a limited extent. Okay, so straight into it, the block size alter function. So the idea here is you have a, how can I put it, we have the new technology of buffer pools, and that's a really great idea, but you have all your data sets currently blocked at a single size. That's been what you've used all along. Maybe a few data 2 buffers, but basically the same block size. So now you want to exploit the buffer pool technology, and you want to put some new block sizes, and in some cases you can't afford the outages that would take to rebuild a large area into new blocks. So what we have here is a technology that's built on the back of the successful online area move, and we'll talk more about that technology in a moment. So what block size alter does is moves the rows one by one from one physical location, one physical area to a new area. What you're getting here is you're altering the block size while the area is still available for normal application access, no outage. The internal technology I refer to is a technology that tracks where each individual row is as they're moved. So when an application comes in to look at that area you're moving, this technology knows where the current row you're looking for is, and it can go straight to that location. It's either in the old area or the new area. Datacom knows where it is. As with a lot of these new technologies, you have to pre-allocate a new area with something called a PreInit, and we'll have a look at a couple examples of that. The block alter technology is activated by a startup parameter I mentioned here, and it's actually initiated by a data dictionary update execution. Think about what you're doing here. You're actually changing a fundamental attribute of the data set, its block size. So as well as moving the data and reblocking it, you actually have to update the dictionary and the CXX at the same time. So that's why this technology, unlike others, is actually initiated by a DD update. Okay, so the target area must be using buffers that are large enough for the new block size. So you consider you have an area out there that's blocked at 4K, and it's currently residing in regular buffers. But you're going to reblock it to 32K. Obviously, that's not going to fit in a 4K buffer anymore. So what you have to do is manipulate that area into 32K buffers before you even start. And that may require a bounce of MUF in order to assign the area to a buffer pool, which is otherwise too large for it, but will become the right size when you move it. Or there is a parameter called block size alter data 2, which means that when you start the MUF up, the databases you specified of this parameter will be forced into data 2 buffers. Even though their size would not normally indicate that, Datacom will force them into data 2 buffers, and if the data 2 buffers are large enough for the new block size, that's where they'll stay. I'll show you a bit about that later on. And finally, we'll see examples of the status message, and what that will include, I've mentioned here, is both area and table names. What you're doing here is moving an area. That area may be multiple table names. So the message will include both area and table names so you can check its status. A couple of key benefits with this technology. Since you're moving the rows one by one, you're moving them by native key, so the function is effectively reorganizing the tables without an outage. No matter how disorganized your area is at the beginning or your table is at the beginning, this function is going to put it pretty much in native key sequence subject to new records being added at the time. So that's a major benefit. Another major benefit is that you can allocate your target area smaller than the source area. So you can use this function to effectively resize an area. If you've got a database allocated at 100 cylinders and it's only using 50%, you can allocate the new one at 60 cylinders. Therefore, you're downsizing that area as you do the reblocking. I think those are two very useful benefits. So a quick diagram. I like pictures for those who have seen my sessions before. So what we consider here is we've got the application, the top right-hand running against this table called APN. And down at the bottom on the left-hand side, we've got the APN area, APNA. Okay, everyone's processing quite happily. Now you allocate PreInit a new APN area on the right-hand side there. It looks slightly different because it's a different size, and it's internally different because it's a different block size. You then initiate the DD update transaction here to actually start the move. And what that is doing is exploiting these two new technologies I mentioned before. One is the row mover routine. The row mover routine just moves the records one by one. At the same time, what they're calling the record locator gate, actually I don't know how official that is, what I'm calling the record locator gate is identifying the rows that have been moved and where they belong. So as your application continues to access APN, it knows to go to either the old area or the new area as the move takes place. So that's a quick picture of how this process works. Here's a look at some JCL. I mentioned the PreInit. So with DB, standard DB utility, allocating a new block size, giving it a new unique name of your own by your own standards, the space that you think is appropriate for this, secondary allocations, in case you need to do a dynamic extend, we'll talk about that later, and the new function is PreInit. The block size on the new function is what you want the new block size to be. There's another parameter, a new report here is the type equals P report on the CXX, which lists all existing PreInit data sets that currently exist on the CXX. The output from the, someone's not on mute. The output from the PreInit is shown here as your standard CXX status information thing. Block size of 32K, 15,000 blocks, blah, blah, blah. This is the output of the PreInit report showing so that on this date and timestamp, I allocated a 15,000 track extent data set, and this is the data set name. So at any time, you can report on all existing PreInit data sets out there. That will be removed at the completion of the move, and we'll talk about that when we get to that slide. And this is the DD update job to actually initiate the move. Again, the area occurrence name, you'll recognize that. I know you won't, I guess it was a different one than what was in my earlier ones, but this is the area occurrence name. It's on prod status. You're operating against the production version. We're doing a 1000 alter, and the 1500 transaction is a block size change and the new block size on there. Very straightforward. And here's some examples of what the job executing, the status messages. So the job starts and the job ends. The dictionary update job ends very quickly because all that does is goes and update the dictionary and updates the CXX and then initiates the process. The status messages for the move itself start with the block alter 24/7 message. I'm preparing to start. Further down, I'm actually started. I'm moving the block size from 4K to 32K. And at this point, I've moved row 0 out of 5 million rows. So that's just your very initial starting point. Sometime during the process, we're going to produce status messages. So at this stage, I've moved 4 million of my 5 million rows. And I alluded before to area and table name. This is the area name, and this is the table name. In this case, it's a single table area. But if you are stepping through multiple tables in a single area, then the table name will be changing within the status messages. This demonstrates here the capacity of the block alter 24 to dynamically extend the target data set. If you've underallocated, as I did deliberately in this case, and the area is predefined with dynamic extend, then an extend will take place during the block alter. So the standard dynamic extend messages. The database status message shows you what this is going to look like in a status command. The job name is internal job name. The ID is a console block size change, so you can see what it's doing here. You can also see how long it's been running, how many IOs it's done so far. And finally, when it completes the move, then it's going to put these messages up there. I'm starting the close process. I'm going from volume TPNS03, internal evolved name. I'm scratching the old data set. I'm renaming the new data set to take the place of the old data set. So there's no need to change any CXX here. The new data set is going to be called what the old data set was. And then it's going to tell us that we're complete. The database is still open. The area is still open. We've run for 6 minutes and 38 seconds, and we've done 434,000 IOs. So you can see, as an indication of how quick this is, it's moved a 5 million row area in about 6.5 minutes. And there hasn't been an outage. Applications have continued to run in that time, and it's now done. The area is reblocked. Couple of little miscellaneous factors here. So this is a CXX pipe equal A report before and after. So you can see we started off with 208,000 blocks. We've now got 27,000 blocks. We started out at 99% full. We're now 94% full. That's purely coincidental. I wasn't aspiring to make a little more space available. The next line down, the bottom part here is a dynamic data NE report. For those of you who are familiar with it, it's reporting on the efficiency of the read next process. And as you can see, we've come out of this at 100% efficiency. So whatever it was before, we have fully reorganized this table as we did the block alter, as we did the area move. The start option here, I mentioned the block alter yes function to actually activate the capacity to do block alters. And in this case, I have a parameter set up to move base 450 into data 2 buffers. 450 would normally go into regular data buffers, but I want it moved into data 2 buffers for the purposes of this multi-user execution, so I can do a block alter on base 450, moving it to some size that fits in data 2 buffers. If you do not have the alter yes in your startup parameters, then you will see this message when you try and do a block alter function, block size alter, no or off. Finally, there will be situations where you allocate a PreInit function data set and you don't want to use it for some reason. So there is a delete PreInit, CXX mate, dPreInit, specifying the area and the database ID in that data set. That entry in the CXX will be the entry in the CXX will be dropped. And I'm going to go into mute for 1 second. And you then have to remember to physically delete the data set. This delete PreInit will not do. So that's block alter. Now we're going to move on to the second of these two similar functions, online area move. So the is a similar idea to Block Alter 24. It's actually an idea that was formulated after Block Alter 24 was completed, as the developers saw the potential here. Like BA24, it moves rows one by one from one physical location to another physical location. This time you're moving just a table, not an area. Technology is the same. It tracks row locations as they're moved. And again, the target area is pre-allocated by the PreInit function. This time, because you're not changing any key dictionary attributes in this process, you're not going to need to do a DD update. You're going to be able to make the function, provide the function by a console command like you did the old online area move function. Other benefits, the same benefits as for the other functions. Since we're moving by native key, we're actually reorganizing the table as we do it. And this I see as the main benefit of this particular utility. Real-time reorganizations of the table without closing the table. And similarly to the other function, we can also resize the table down if we wish to using this function. So just to select the differences, if you just want to move an area or reorganize an area in real time, then, and you're not changing the block size, then you do the table moves. You wouldn't do the area block alter. If you wanted to change the block size at the same time, then that utility gives you benefits of both worlds. Another diagram that's very similar to the diagram previously. Same as before, the application's processing away quite happily. Got the initial table and its own location here. Got the new table, which I've designated here as slightly smaller. This time your console command to do the move. And you can see here I haven't properly edited this function. I'm actually moving base 489 and table APN. Move the same technologies as we used in the other ones, the technology and the row locator gate, and you're moving rows one by one by native sequence key into that new location. Very similar to the other one. The PreInit function is going to be the same. This time the block size must by definition be the same as the block size for the current table, because you're not allowed to change it with this function. Same output report and the same PreInit report from the report function type equals P. So the quick console move, in this case I'm using a new facility of option equal console, option 2, and we'll talk about that later on, but it enables me basically to issue a console command from a utility. So I'm doing an online underscore table underscore move, database ID, and table name. It's going to look very similar to the other one. The job itself starts and ends very quickly because all it's doing is executing the console command, issuing the console command. We get the message saying that we're preparing to start. We get the message saying we've started and we've moved row 0 of 1 million rows. This time the status mode actually finished too quickly for me to get a inline status, so I did a database status at the time, and it shows what we're doing here, an online move DS function, and this time it's identified as a console online online table move. The same process occurs at the end of the execution. We start the close open process. We scratch the initial data set. We rename the new data set. This is all done under a lock, so that no application suffers while this very quick process is taking place. Proudly boast at the end the area is still open. Ran for 1 minute, 5 seconds, and we did 77,000 IOs. So again, we moved a very quick 1 million record table in very quick time, same time performing an online reorganization. See here in the report, I've actually used this as to downsize the table from 37,000 blocks to 27,000 blocks. So I'm gone from 63% full to 88% full. I did a bit of a downsize. And once again, we come out of the process with the table in 100% efficiency as far as read next processing. Achieved our online reorganization, which was the idea of it. On to the Add Native tool. This was designed as an assist for customers to use when they're populating tables for which online sequential read is very important. So they might have a table out there which they're adding a lot to and deleting a lot from. And as the second bullet here says, it's ideally suited for when you're adding and deleting on columns that are not the high order part of the native key sequence. So as you can see, as you delete a few billion records each night and add a few billion new records on the non-native key sequence, the table is going to get out of native key sequence very quickly. So what this process is doing is as efficiently as possible, it's trying to add the new rows alongside current rows which share the same high order native key. And by alongside means, of course, into adjacent or the same block as the current rows. So when you're retrieving by native key sequence, you're getting the records alongside their peers as often as possible. So the price of this feature is you're getting slightly lower adds because the add is going to search out a location. Instead of throwing it in the next available block as normal adds do, it's going to search out a location to put them in. But if you're willing to pay that price, the benefit is that your nightly or daily sequential read function is going to run efficiently for a lot longer than it used to do. Long-time Datacom customers may remember or know of the cluster key option, which still exists, but I'm not sure how many people actually use it. This is designed to be a more efficient and less expensive version of the cluster key option. So what we're aspiring to do here is reduce the need for regular reorganizations of your big tables. And even though the 24/7 type reorganizations, the reorg or the online reorg or the TM24 I just talked about, make these reorganizations less intrusive, they still run, they still take up computer cycles, and they still have to be scheduled and checked. So if you can do less of them, that's still a step in the right direction. So as I've alluded to, this is a feature that's under development. So while it ultimately will be implemented as a set of attributes in the dictionary, right now it's being initiated by I hesitate to use the word bastardization, of the CXX main option alter logging function. So option alter, table name, database ID, logging, yes, but you're not actually affecting the logging because you've got these special parameters on there in priority 1 growth. Priority 1 turns the feature on for this particular table. Priority 0 turns it off. And the growth will ultimately be the portion of the native key sequence which you are using in the search function. I alluded to the search function that's going to take place when you add each new record. You may want that search function to find an exact match on the native key of that record you're adding, but obviously that's going to be more expensive. You may be willing to have it search for a table that has the same high order 10 bytes of the 15-byte key, and that will be more efficient on the add. The native sequence query might not be as efficient as what it would have otherwise been. So that's a tuning option you have as you use this add native feature. So there's restrictions on what tables it's eligible for. It's got to use either the random or the wrap declamation method, data space option 1 or 2, or their versions that have the delete a block index, which are database options 4 or 5. So it's got to be using one of these data space options. It's got to be inside an area that has the URI option set. It's got to be inside a base that has optimized. Hopefully everyone's using URI and everyone's using optimization by now. You can't be doing it on a full or any parent of a partition table. So those are restrictions. The add native function here, this is what the CXX is going to look like once you've turned on the feature for a certain table. The cluster key ID you're familiar with, the auth ID and tables SQL name you're familiar with. This is where the new stuff features in. cluster key length is there and probably always 0 unless you're using cluster key. Now it will change to indicate what your prefix is or what your high order part of the native key you're using for the add native. In this case, my native key is 12 bytes, so I'm using the entire native key. And then it's just telling you that the option 1 is currently set. It will be 0 if you're not using add native in this table. These options, these values out here are future enhancements. They're not in use now, so they're going to appear by 0. They're going to appear on your report, but they're going to appear as zeros right now. So that's what the add native looks like. I've got no examples of it yet because I haven't found a really good table in my test system that's good for this feature. But you can see, I think, from the way it works, how beneficial it's going to be for those tables, those few tables for which native sequence key is very important. Okay, so I'm going to talk about some of the other features that are being added to version 15.1 as we go. For those of you who use covered and virtual areas, 15.1 now expands the capacity. I think for the current ones, it's at 9 gig is the capacity you can allocate, which means a single table, a single area can be no larger than 9 gig. In 15.1, with this feature activated, you can now go as high as 19 gig. And that enables me to add a covered startup parameter for this base BLG602 at 15 gig. So you can see the benefits of covered. I don't know how many of you use covered in virtual. We use it extensively here. You can see the benefit in the issue display and an accounting report after you run this table, reads of this table a few times. You see that this BLG is covered for nearly 4 million blocks. During my testing, I've read it 2.4 million times. Active reads have only been 766,000. So these memory reads 1.64 million times. I've benefited from using the covered feature when the facility has found the record in memory and it's saved an I.O. to disk at all. So 1.6 million times I've saved my I.O. during this test scenario. See the effect on performance. When I first read this table in this run unit, I did 4 million reads, 856,000 I.O.s, and the average response time was 0.16 millisecond, which is great in itself. But as I reread this table later on, same number of reads, same job, I now only need to do 90,000 I.O.s, and my average response time was 1/5 of the previous response time. So I think we all know the benefits of covered and virtual, but this allows you to put much larger areas in covered and virtual space. Okay, I alluded to this enhancement at the earlier part of my session, the new option 2 on the console command. It basically enables you to issue more and more commands as console commands via DB utility rather than having to put them in by hand. So you can schedule more and more commands to be issued by utilities. The format's very straightforward. You issue the command within quotes if there's embedded spaces. Or no embedded spaces, you issue it as the correct command with the prefix /F. Modify command -status log, and these ones have embedded spaces so that you put the quotes around them. Console with wait, I think, is a fairly new command in 15.1 that will basically go out and issue a pending close on a base. It will tell you what tables have it open, what applications have it open, enabling you to close those off, and then the close will complete. Instead of having to reissue the close when you're finished, closing everything, the close will complete after the initial close with wait. Status base to tell you the status of the wait of the base you're looking at. Status log to tell you the status of the log file. I think they're all new commands. There's a trivial looking but useful enhancement to the status command that you'll get without even knowing it, just as you go through the normal maintenance process. For a task that is task active status, i.e. active in the MUF and not doing anything, in this case I think I set up an exclusive control wait to see what it was doing. It's now going to embed a little timestamp so you can see how long it's been in that status, in this case 26 seconds. The same is going to apply to a task that's not active. How long has it been not active? Well, in this case, it's been not active for 18 seconds. So that information is not currently available to you. It enables you to look at take a quick look to see how long the task has been in that status, and that might be useful information to you at any given time. Note that it does roll over quickly. It's a quick and dirty design, and it will roll over after 9 minutes and 59 seconds. But again, that will be in itself an indication that it's been out there in that long a status, and maybe it's something you need to be concerned with. Now I'm going to look at a few features that were supplied in earlier releases, just in case they're slipped by. I think this is going to be very useful. The add, delete, and move key 24/7 feature. So the idea is here that you can add a new key. I think it was 15.0 this came out, and it was one of the key features of 15.0, a major enhancement. You can add a new key on the fly. You can delete a key on the fly. Now, what you're going to do if you do a delete is you're going to use an option to turn off access to that key. If you think it's not used anymore, there's an option in the CX to turn off access. Key exists and remains maintained, but you haven't taken away access, so anyone who tries to use it will get an error message, and you'll be able to decide whether their access can be changed or whether you need to reinstate the key. But you're not going to physically delete it till you know for sure it's not being used. And then the move key refers to the idea of moving your key within the multi-data set index, whereby you're still having an IXX, you have an IO1, an IO2, and IO3. You can tune a base by moving your key from, say, the IXX into the IO1 area while the base remains open and fully accessible by the applications. This feature involves a little data dictionary work. We're going to add a new key definition. If you're just adding a new key, and it'll be a new key definition by design. If you're moving a key, as I am in this case, it will be the image of the current key, but with a different key ID, highlighted here, key ID 931, and a different area name because it's currently in IXX and I'm moving it into IO1. Then you're going to do a series of DD update processes. And in this case, the first one is going to be updating the key, the occurrence name, SREK, XXX, and I'm doing an apply CXX, and that's going to build the new key definition in IO1 using key ID 931. When that's complete, you now have the key out there twice, essentially, so now you're going to tell the system to swap the keys. So for this key SREKC, the original name, you're going to swap it to use this XXXKC number. So effectively, from this moment on, all applications will be using the key in IO1 and not the key in IXX. Both keys still exist out there on the data set, but SREKC is now pointing to the new location. And then once you've finished that, then you're going to, happy with everything, you can do a delete function, and that will delete the now called XXXKC key in the IXX data set using the apply CXX. So this is for a move, it's a three-step process. Now for an add, it will be a single-step process. You'll just do the apply CXX update key, and that will build the new key for you. It will be available as soon as you've done that. For the delete process, you'll just run the delete key when you're ready to go, and that will delete it, and that'll be the end of that process. For the move, you're doing a three-step process. But essentially, you've tuned your index by creating a new key without an outage. I mentioned the key usage function. I have a note here to mention it explicitly. The key usage attribute that you can change with the 1000 alter dictionary process, and that will turn key usage off, preventing anyone from using that key, so you can determine whether it really is not used as you suspected. I mentioned the online area move, which is generated the technology. I think these features all came in, I think, even release 14, if not 14.02. The online area move process, which invented the technology that's used in the TM24 and BA24. And the idea is you're just moving an area from one volume to another volume, not changing the block size. But once again, you have to do the PreInit, pre-init the new area with the appropriate block size. Once again, because you're not altering any dictionary attributes, you are issuing this with a console command instead of a DD update dictionary command. What you might be doing here is if you've got some new DASD, and a while ago we swapped out all our DASD from older technology to newer technology. Obviously, moving from one to the other is something you could do using the FDR technology or some underlying this technology, but you can also now use the online area move function to do the move for you. Data set is open all the time. Applications are running quite happily. Another useful enhancement from an earlier release, the online area release situation. This is a situation where you've allocated your new area and you've discovered it's been well over allocated. So you look at it after a few years or a few months and you've only used the top 10% of that. So what you want to do here is basically just release the extra storage you're not using. Unlike the Block Alter 24 and the TM24, which you can use to diminish the size of your area, what you're doing with this one is it's a very quick process. You're not moving from location A to location B. You're just basically dropping the unused extents. But what that means is that it can only drop to the high use point. If your data is scattered all over the data set, then you're not going to be able to use this function to drop it. It's only going to drop at the high use point. So what you're going to do first is you're going to activate the high use feature using the data scan technology of release 15.1 and the option set data high use. So this is going to read through the data set and determine where the high use marker is. It might be on cylinder 10. It might be on cylinder 15, which belies how full the base is, but basically it means you've got an embedded space. Once you've set the high order mark, then you can use this online area release function to say release up to 80% of the unused space. So if this area is 100 cylinders, the high use mark is coming at 20 cylinders, meaning 80 cylinders are unused. You want to release 80% of that, so you're going to release 72 cylinders. You're going to leave 8 cylinders unused space top for expansion, but you're releasing the other 72 cylinders. And that's a very quick command. It just goes out to the appropriate MBS facility, and I guess it uses the same technique as the MBS JCL release command. Okay, change compression, change table compression option. I'm sure we've all had situations in the past we've decided that we either want to add compression to a table, we want to bring compression on a table, or we want to uncompress a table that's already compressed out here. And up until recently, this has required you to unload, change the dictionary definition, and reload. And obviously, that's an outage. This feature enables you to, on the fly, decompress or compress a table. I won't go into all the details. It's very similar to the other move technology we've talked about earlier. But basically, this is a dictionary process, so you're using the dictionary technology rather than the console command to do it. You're doing a 1000 alter. You're just saying compression no. So this is uncompressing the table while the table is open for access. It's going to take up more space, uncompressed, so you have to take that into account as you run this process. Okay, so we're into the summary page. We're looking very good on time. So as you've seen from these and many other enhancements, the big feature of Datacom technology these days is the 24/7. That's the big emphasis. Doing more and more without outages as shops require their database environments to be available more and more. Now you have access through websites and around the world. It's stuff people are going to need to get to it all the time. You can't afford long windows to rebuild or reorganize tables, to add keys or to delete, move tables to new DASD subsystems from old DASD subsystems. So you're going to be able to do those 24/7 now. There's features we've talked about that address performance of a sequential access. job or jobs is very important to you. You now have a new technology to improve that performance and keep it good over a longer period between reorganizations. You now have technology to cover larger areas. Instead of it being the very small reference tables that it used to be at the start, we can now look at decent-sized tables and cover large chunks of those to improve the performance on those tables. And there's usability with the COM functions and other new usability functions. There's a lot of new technologies that they're rolling out in 15.1. So what I'll do here is a shout out for DocOps. I hope you're all using the DocOps technology, getting to the table, getting to the manuals on the website rather than through your own copies, downloaded copies of them. Because what you're seeing is that the technologies, as they're added to the software, documentation for them is going into the DocOps base very quickly. I think that you saw a note from the community just yesterday or this morning, PreInit, I guess, pointing to the latest series of enhancements that are now documented in the manuals in DocOps. What I will caution you here is remember when you go to DocOps to sign on using your CA sign-on process, because without you knowing it, a lot of the features, a lot of the manuals are hidden to the person not signed on. It's not clear to you when you do a search on a feature. You get what you think is all the information on that feature, and then to remember, oh, I didn't sign on, so I'm not seeing everything. So it's caused me frustration on a few occasions, so I would caution you, sign on to DocOps as soon as you get to it, and then you'll see everything that's available, not just the public information. And I think that is it. Blah, 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 blah. Questions, we talked questions. I've been instructed to give a shout out to the Cadre Technical Conference, which it's going to be scheduled for April the 16th to 20th in Plano. Those of you who came to the conference last year, yes, enjoyed it a lot, I think. So the next one will be in April next year, so mark that on your calendars. And do we have any questions? Nancy, I'll pass it back to you.
Okay, thank you. We have a few minutes left. Do we have any questions from the audience?
Yeah, so Clyde, I've got two questions for you. One, since we can now change using the alter block size, we can change to a standard or a couple standards at the site for our data block sizes. What are your standards, or what have you adopted as a standard for data block size?
I would have to say we have not adopted anything as a standard yet, because the block alter technology is still in its infancy, in that it's not actually a released feature yet. So we're not using it in a production system. What I can say is that we have allocated some some image files at a block size of 12K, and we used the Data 2 technology to initially support those block sizes, and we're now using Data Pool technology. I would say probably going to go to like 24K or whatever that is, that's half-track blocking. I think that's probably the optimum for our 3390 type devices, and then 4K for the reference data sets, small data sets where we don't need to get as many records of memory with a single I/O. So 27.5K or whatever it is.
Right. So the maximum size is 27,998 on the data set, but use a 28K buffer because it just gives it better buffer page alignment and so forth.
Right. If you go to 32K, you're not going to fit two on a track. So 32K.
Right. Right. So it's 27,998 is the highest performing block size for a data set, and then using that with a 28K block size would be my recommendation. Second question, have you done any kind of benchmarking between using the table move process to do a reorg versus the online reorg?
No, I have not. Again, same thing with the table move technology. It's not yet fully fledged, so I've just got to play with the data sets available on my test system. I would suggest the table move is probably going to be a little bit slower because of what it's doing. It's reading every record in native key sequence and moving it one by one. The benefit, of course, is that it's going to give you a much more pure reorganized table than the other feature, because it's a moving by native key rather than the online reorg is just chunking rows together in approximately native key sequence in a very efficient manner. TM24 is moving row by row. So what you're going to use here is whichever is most suitable for the table. It depends how key 24/7 access is to you and how often you want to be doing the TM24.
I think
that would be slower.
Yeah, so you have an online reorg reference group 0, which moves every row also. It does have some high performance in there where it'll skip rows. Where I was thinking with where TM24 is very interesting is I have some sites that can't give every data set they want to reorg a 20% free space for whatever reason.
Yep.
That OL, we recommend for OL reorg reference group 0, but they can give some, duplicate space for a temporary period of time. So you could do a TM24, and as soon as the reorg is done, then you can give back the original data set. So you could go from a 94% whole file to a 94% reorg file using TM24. Temporarily you have to have a bigger pool of DASD, but you can get that back pretty quickly.
Yeah.
And the other thing is TM24 would also remove the extra extents. If you happen to have, reorg won't compress from 10 extents to 1 extent, where by default TM24 gives you the capability of going to a single extent.
Right, and if you want to play fast and loose with your allocations, the TM24 does support dynamic extend. If you want to take that risk, and you're getting back to multiple extents that way, but it is there as a backstop in case you mess up. Probably the ref group 0 may run as slow as a TM24. That would be an interesting benchmark.
TM24 gives us another way of doing reorgs, and it meets a couple different things, because if you have to reallocate your sizes, it lets you do that at the same time, and it also handles the case. Because I have run into that at one specific site where they did have DASD available temporarily on a weekend or whatever, but didn't have it available all the time. So they couldn't expand every data set to 20% free space, but they could get a data set available for a period of time.
Yep, makes sense.
Right. Thank you.
Okay, thanks. Do we have any other questions?
Yes, this is Michael Flores. I have a question.
Okay.
Since version 15.1 only utilizes the database for the CARS maintenance methodology, and CARS is the only method that we utilize, is there any issue with using the version 15.1 database and then having version 15.0 for the other products, IPC, Agile, and CICS services?
We're running that combination. There is no issue. We're running that combination in production and non-production right now, because from our perspective, 15.1 is more mature. 15.1 database is more mature than 15.1 of the service facility or IPC. Actually, I think we're running Datacom 15.1 and IPC 15.1. You'll find that as far as your maintenance is concerned now, IPC has been pretty much folded into Datacom. It no longer has its own product note on the MSN or CSM pull-down menu. When you pull down database maintenance, you get IPC maintenance as well. So I think we chose to stick with IPC 15.1 and database 15.1, but we're still running 15.0 of the service facility and 15.0 and 14.02 of the server. There is no issue with those mixing the releases as far as I know.
So you're utilizing the incremental for 15.1 IPC?
Yeah, we're using 15.1, yes. I think it's probably very similar to 15.0, the upgrade from 15.0 to 15.1. Very similar. I imagine the IPCs are very similar.
Okay, so there wouldn't be any harm with us using 15.0 for IPC with CARS?
I played with that combination in my test period for a while. I would recommend opening a case with CA just to double check, but I suspect it'll be fine.
This is Dale Russell. Just one comment. We typically expect, if you're an Ideal shop, that IPT and Ideal are the same release.
All right, that may be a more important criteria then.
Okay, with that being said, then we probably stay with 13.0.
Okay. Yeah, I'm confident it'll work. As I say, double check with CA. Okay, you're welcome.
Okay, we probably have time for one more question.
Good day, stranger.
Hey, good day. How are you, Phil?
Hey, pretty good.
Good.
I had a couple questions. On the TM, are you going, or is there any, I saw it did a scratch of the old data set. Could it be renamed?
I know that was technology that was available in online area move, and it may well still be available in online area move. I believe they abandoned that technology with TM24 and BA24.
So instead of scratching, the rename, it couldn't rename like to a .old?
No, I don't believe it does anymore. It just scratches. Now, both functions are restartable if the process doesn't end. In fact, I'm looking at my test muff right now where I didn't allocate enough space for the target of a BA24, and I forgot that that particular area does not have dynamic extend. So my BA24 ended with a return code 7 partway through, and what I see now on my map is an incomplete BA24 status. My applications work quite fine. The data is in 2 locations quite fine. And when I get round it, I will extend the target data set and restart the BA24 to complete it. So I think the technology restartable and is mature enough that they feel there's no need for that rename option, and they just go straight to a scratch and replace.
Okay, does this clean up the move data space pointer?
I guess it would, yeah. I hadn't thought about it, but I guess if it's reading a native key, it's going to go straight to where the record is and move it to the new location. The index will reflect the new location. So unless Kevin or Dale, you want to correct me, I would say it does eliminate, get rid of all the move data.
Well, 2 things. One, on the first question, Phil, that it does not support the rename that could be added if needed. We had the rename on the old online area move, and most people didn't want it because it just left the data set. What we did was we renamed the old data set to the same data set name a hex timestamp, basically representing, right? So that could be added if needed. We took it away because very few people seemed to want it, and it was just another option you had to specify, and we're trying to reduce the amount of options that people have to know about. On the moved record, I think you're really talking about the MRI, which is a part of the global index. And with the moved record, the TM24, it does not change the algorithm around the MRI. There is a moved record index as before. Now, I will tell you that we have brought this up with development, and we are looking at stories around a way that once you complete the process and you have a certified backup, that you could initialize the MRI or free that space back.
Okay, thank you. On the how does all this moving stuff impact your indexes like NDI?
Clyde, I think that's
I'm on mute. Yeah, I'm on mute. Not at all. One of the databases I've been playing with in those examples was an MDI database. The index is obviously going to point to the new location of the record once it's been moved into native key sequence, but it doesn't affect it at all. You're moving the area. This is all data stuff, Phil, not index stuff.
Right. Okay, 4th question and final. Okay, on the open close messages, there was a request to add a task ID. Was that ever considered?
Not a question for me.
Bill, this is Dale. I'll maybe talk with you offline and make sure. I think we have your request in there, but let's make sure that it's in our backlog.
Well, there were changes recently in a bunch of status messages, so where we put out a lot of the information you requested. I know that.
We'll talk to you later.
Yeah, we need to look at the 15.1 because there's a whole series of updates to COM status messages and the status commands.
Okay.
Very good.
Well, okay,
thanks everybody.
Thanks, Clyde. Thanks, everybody. I'm going to take down the WebEx, and then I'll try to to bring it up in time for the top of the hour for our final one for today. Okay, thanks. Bye-bye.
Thanks, Nancy. Appreciate it. Bye.